Hello, students, and welcome to the review for Unit 3 of Geometry A. This unit is called Angles and Parallels, and as you might imagine from that title, you learned a lot about different kinds of angles, how to name them, how to measure them, how to calculate them. Also learned how to work with parallel lines and transversals that create a lot of angles. And this review won't cover everything that we talked about in this unit, but it will cover those things that you need to know for the test. So pay close attention and take some notes. If you have any questions after listening to this, please let me know when you call, or you can always watch this over again. Let's start out with just some definitions of different kinds of angles. You might be familiar with these, but maybe they're new. If an angle has degrees between 0 and 90 degrees, then it's a very small angle, and it's called acute. I remember this because most small things are cute, most cute things are small. So acute angle is the smallest type. If it has exactly 90 degrees and forms a corner, then it's called a right angle. And this would be like the corner of your computer, the corner of your table. Most things that we build and are sturdy are formed with right angles. An obtuse angle is greater than 90 degrees, but not as great as 180. I remember this one because the word obtuse is sort of like obese. Obese is big, and these are the biggest type of angles until we get to this straight angle. Straight angle is just a straight line. It doesn't look like an angle because we think of angles as having a vertex, and there's no way to identify the vertex in a straight line. But if you measured it, it would be 180 degrees from one point on the line to another. That's called a straight angle. Now, one thing that we did in this unit is to look at the measurements of different kinds of polygons. A polygon is just a straight-sided figure. It can have any number of sides from 3 to infinity. And as you know, the more sides you add to a polygon, the bigger the angles between those sides becomes until it becomes almost a circle. So there is a way to figure out the total number of degrees on the inside of any polygon. And it's this formula right here, 180 degrees times n minus 2. Well, why is that true? Well, if n is the number of sides of the polygon, you can draw a certain number of triangles inside that polygon, but from any given vertex, you can't make a triangle with the vertex next to it on the left or right. You can only draw a line across the polygon. So the number of triangles that can be drawn inside a polygon are 2 less than the number of sides. So, for instance, the interior angles of a triangle would be 180 because it has 3 sides. If you subtract 2 from that, you get 1. 1 times 180 is 180 degrees. And so the total number of degrees inside a triangle will always be 180, no matter how big the triangle is, no matter how regular or irregular it is. That's the reason why you can't have 2 right angles in a triangle. If a right angle has 90 degrees and you have 2 of them, that's 180 degrees already. You don't have enough degrees left to make a third angle, and as you can imagine, 2 right angles in a triangle would never have the 2 sides closed, so it could never be a triangle. Interior angles of a quadrilateral, meaning a 4-sided figure, would be 360 because 4 minus 2 is 2. 2 times 180 is 360. So any quadrilateral, a square like the one I've shown down here, or a rectangle, or even one that doesn't have regular sides, is going to have angles that add up to 360 degrees inside. Now, we also talked about exterior angles. Exterior angles are made by extending one leg or one side of a polygon and looking at the angle that it creates with the next side. you'll notice that in each of these three examples and in every polygon, the sum of the exterior angles of any polygon is going to be 360. So they're pretty big if you look at the ones outside a triangle. This is a regular triangle, and each of the exterior angles is 120. There are only 3 of them, and they add up to 360. In a quadrilateral, you can see the external angles are also 90 degrees, and there are 4, so they add up to 360 as well. Even in a pentagon, which I think is the question in your exam, even though they're getting smaller, there are more of them. They measure 72 each, and if you multiplied 72 by 5, you would get 360 because the exterior angles always add up to 360. Now here's a question I found on your on your test. Approximately how many degrees are in the measure of the interior angles of a regular 7-sided polygon? Well, how would you figure that out? I'm going to go straight to this formula. 7 minus 2 is going to be 5, and 5 times 180 is going to be 900. So I know that the total number of degrees inside a 7-sided figure is 900. This says it's a regular 7-sided polygon. That means every angle will have the same measure. So all I have to do is divide 900 by 7 and figure out how much each one of those angles would be. I know this isn't going to go in evenly, so let's just figure this out using division, and you can use your calculator, of course. 7 goes into 20 twice with 6 left over. If I bring down the 0, that's 60, and it will only go in 8 times. And that doesn't come out even, so we're going to have to go into decimals, but it did say approximately. So I'm going to bring down another 0 and add that decimal. 7 goes into 45 times, and that would be 35 with 5 left over, and 50 would require 7 sevens. So if I were to approximate the degrees in a single angle, and I think this is a multiple choice question, next one is only going to be 1. So it's either going to be 128.57 approximately, or possibly the answer would be 128.6. Either one would be acceptable for the approximate measure of an interior angle of a regular 7-sided polygon. Okay, now when we're talking about parallels, we are creating lines and angles that use a transversal. So if you look at this illustration down here on the bottom, you can see that line L and M are assumed to be parallel, and that there's a diagonal line going through here, and that's called a transversal. It creates 2 sets of 4 angles that all have a relationship with each other. They're either equal to each other or supplementary. It also has a second line that's perpendicular to both of those lines that's going through and creates its own set of angles. From the measure of one angle, we can determine all of the others. So let's start with this one up here on top where lines L and M are considered to be parallel, and we are given that the measure of angle 3 is, we're supposed to find angle 3 if the measure of angle 5 is 38 and the measure of angle 6 is 62. Well, that doesn't give us enough information to find the third angle of a triangle, but we'll see if we can use this information about the lines being parallel to help us out. First of all, I know that up here, I've got a straight line that contains these 3 angles. I know that a straight line is 180 degrees. So if I add up 38 and 62, I would get 100. And if I subtract that from 180, I know that this third angle that isn't marked is going to be 80 degrees. Now, because these two lines are parallel, and I know that there's a relationship between this 80-degree angle, angle 7, and this angle 3, these are called alternate interior angles of this transversal. The transversal coming down like this, passing through two parallel lines. Alternate interior angles have an equal measure, so I know that the measure of angle 3 will also be 80 degrees. So, some very handy theorems to know. Now, let's take a look down at this next problem, and it says find the measure of angle 1. Well, I've got a transversal here that's going through, but it doesn't look like angle 1 is on the same, has a relationship to this transversal. Well, actually, I think that it does. Okay, so looking at ignoring, well, no, we're going to have to use all the information given. Okay, so using this dotted blue line that I've kind of penciled in here as the transversal, I know that an angle created right here is going to have the same measure as the 30-degree angle that's listed below. And because this other transversal, and I'll just outline that one in red, is assumed to be perpendicular to these, I know that this angle right here is going to be 90 degrees total. Well, if it's 90 degrees total and 30 degrees of it are already measured, then this other one has to be 60 degrees because 90 minus 30 is 60. So from the information given, I can figure out that angle 1 is 60 degrees. Okay, now polygons have specific names up until we don't. And we could call something a 7-gon or a 3-gon or a 4-gon. Any polygon can be called like that. But we do have some that we actually have to memorize. One that you probably already know is a triangle. It's got 3 sides, and that's pretty easy to remember because not only we're familiar with triangles, but tri means 3, like in tricycle. Quad, you might not know, equals the Latin word for 4. That's a 4-sided figure. It doesn't have to be a square, rectangle. Any 4 sides will do. Quadrilateral has 4 sides. You might know that our military headquarters in the United States is called the Pentagon because it has 5 sides. Pente is a game with 5 in a row of some discs you might be familiar with. So penta in Latin means 5, and a pentagon is a 5-sided figure. A hexagon has 6 sides, and you might be familiar with this because if you work with machines, a lot of times hex nuts and hex screws have 6 sides. And I remember it because it has an X in it, and so does 6. So that's an easy way to remember that it's a 6-sided figure. Now, most everything we've done so far has been about simple calculations and some definitions, but there are some more complex problems on your test, and I wanted to go through a few of these. Now, triangles are categorized in 2 different ways. First, by their angles. If a triangle has one 90-degree angle, and it can only have one, remember, it's called a right angle, a right triangle, because it has a right angle in it. That's pretty obvious. A triangle can also only have one obtuse angle, and if it does have an angle greater than 90 degrees, it's called an obtuse triangle. If it doesn't have any angles that are 90 or more, then it's considered an acute triangle. Don't be confused because all triangles have at least 2 acute angles, but if all 3 are acute, then it's called an acute triangle. A triangle can also be categorized by its sides. If all the sides are of equal length, it's equilateral, which literally means equal sides. In fact, an equilateral triangle would also have equal angles. An isosceles triangle has at least 2 sides that are equal, And a scalene triangle has no sides that have the same length. So a triangle could be considered acute scalene or acute isosceles. And of course, every equilateral triangle is going to be acute because the angles are all 60 degrees, which is less than 90. But it could be a right isosceles triangle where the two sides on either side of the right angle are equal. So every triangle will have a designation by angles and a designation by sides. Now, the nice thing about triangles, there are a lot of things we can use them for, but if you know two angles of the triangle, then you can always find the third one because you know that the angles add up to 180 all the time. So let's work out that using this problem. So there's three problems that I pulled from your test that I want you to be able to be familiar with. First, in a right triangle, the acute angles measure x plus 15 and 2x. Okay, so let's assume that this triangle up here is a right triangle. I don't know whether it was supposed to be or not, but I'm going to mark it with a right angle so that I know it's a right triangle. And it doesn't say which of the other angles are x plus 15, so I'm just going to assign them. You're supposed to find the measure of the smaller of the two angles. But because they gave it to us in algebraic terms, we don't really know which one is smaller. But I do know that they all add up to 180. So I'm just going to write a little equation. 180 equals the 90-degree angle, the 2x angle, and the x plus 15 angle. And I know that they will all add up to 180 no matter what x is. So just to combine some terms, if I add this 90 and the 15, I end up with 105. And if I combine the 2x and the other x, I get 3x. Now it's a little bit easier to solve my problem once those are combined. The first thing I'm going to do is subtract 105 from each side. And if I do, I end up with 75 equals 3x. Good thing we had algebra before geometry. And then my last step is to divide both sides by 3 and find out that 25 equals x. Now don't stop there. That is not the solution to this problem. They want to know the measure of the smaller angle. Well, this one that I labeled x plus 15 is going to be 25 plus 15. So that total would be 40 degrees. The one over here that I measured, 2x, is going to be 2 times 25, and that would be 50 degrees. So it looks like the smallest angle in this triangle is going to be 40 degrees, so that is your final answer. Okay, let's skip down to question 3. I think that one uses this illustration. What is the measure of angle 1? Well, let's see what I can figure out about this. I don't have any real corresponding angle with this, even though it looks like this line down here on the bottom is going to be parallel to this line up here on the top. And there could be a transversal, but I don't have enough information. But because I know that vertical angles, or opposite angles sometimes they're called, are equal, I can label this angle right here as 40 degrees. Now that angle does have correspondence with angle 1. If you see that this angle and angle 1 are on opposite sides of the transversal, and in between the two parallel lines, they are alternate interior angles, and they would have to have the same measure. So again, this angle is going to be 40 degrees. Same answer to two different problems. Okay, now I am going to get rid of what I wrote up here. I think, let's see. Okay, I'm going to have to clear everything from the board because the second question uses this top illustration. If the measure of angle 2 is 137. I'm just going to label that 137. And the measure of angle P is 58. Then what is the measure of angle O? Here's the one we're trying to find. Well, if we had two angles inside a triangle, no problem. We would just subtract them from 180, but we don't. But luckily, we know that angle 1 and angle 2 are supplementary because together they make a straight line. So I can find the measure of angle 1 by subtracting 137 from 180. 0 minus 7 is 3. 7 minus 3 is 4. So this angle is 43 degrees. And if I add the two angles that I know, 58 and 43, then I get 101. And to find that third angle, I need to subtract 101 from 180, and that would equal 79. So the measure of angle O is 79 degrees. And it looked like I didn't have enough information, but if you think hard enough and remember all you know, you do have enough information. All right, that brings me to the end of our review. I hope that you enjoyed it and got something out of it, that you were able to take notes. If you still have questions or want some more examples of these types of problems, please let me know when you call. And if you don't, that's fine too. If you're ready to go on to the test, fantastic. I look forward to speaking with you, and good luck on the test.